Hello YouTube, my name is Sean. In this video series we'll be building a neural network. In this episode, episode 2, we'll be covering how a neural network corrects itself, the machine learning. If you didn't watch last video, we covered how a neural network feeds in input data and makes a conclusion. And we end it with what happens when that conclusion is wrong. In this video we'll answer that question with how a network learns to make the correct guess. Now, how does the network correct itself? It uses a process called backpropagation. To explain this process, let's first look at how it feeds in data through the network to make a conclusion. First, it takes an input piece by piece in the input layer. Then, in the hidden layer, it weighs the input differently to make subconclusions. Finally, in the output layer, it weighs all the weighted subconclusions to make a conclusion, where the highest output is the network's conclusion. Well, to correct itself and its thinking, the network needs to see how much the conclusion and the subconclusions are in error or have contributed to the error. Now let's see what I mean by that on the last layer. So let's say we feed our network an image of a 4, and it thinks it's a 2. The output layer will look like the following, with all the other output nodes near 0, and the 2 node will be closest to 1. The desired output will look like the following, with all the output nodes near 0, and the 4 node will be closest to 1. What this all means is the network outputted a 1 in the 2 neuron incorrectly, and it outputted a 0 in the 4 neuron incorrectly. This is partly because we incorrectly weighed our subconclusions, which made the wrong conclusion, and we incorrectly weighed our inputs and made incorrect subconclusions. In the last example with identifying subconclusions and conclusions with classifying cats and dogs, one of our subconclusions was dogs are bigger than cats, and then we weighed that subconclusion heavily in the output layer, which ultimately decided for us that the picture of a lion was a dog. Can you see how both weighing the decision too heavily partially contributed to the error, as well as maybe not the best subconclusion to make in general? Adjustments to both the subconclusion and how it's weighed could give us a better conclusion. In the case of a number 4, where our middle section has a subconclusion that supports it being a 4, and maybe that correctly outputted a 1, but it wasn't weighed heavily enough for the 4, and it was weighed too heavily for a 2, or maybe the subconclusion didn't properly isolate the middle section. Therefore, to correct our error, we both have to make adjustments to how all the output neurons weighed the middle section as well as the weights that determine the subconclusions. Now, I recommend listening to that along with the first video a couple times, because that's all there is to the logic and theory of how a neural network makes a conclusion and corrects itself when it's in error, by backpropagating and adjusting how you weighed both input and subconclusions to make the ultimate conclusion about a piece of data, like a picture of a number 4 or a picture of a cat. Now we've covered what the network does to correct itself. Now we'll cover how it actually does this. The process to do this is called gradient descent. This is where we find the contribution each component makes to the total error, or cost of the network. For now, we will say the cost or error of a network is related to the difference of the output we got, which was a 2, and the correct output of 4. To do this, we must look at what the output of the neuron is versus what it should be, and how the output of a neuron is calculated. So the output of a neuron is equal to each input times the input's weight plus a bias. So in the case of the output layer, that would be the output of each subconclusion times the subconclusion's weight plus a bias, which you do for every node of the output layer. Now, we can't directly change the subconclusion's output, but we can change the weight of each subconclusion, which would therefore support a different conclusion. Now, if we go back a layer to see how to change the output of a subconclusion, we can see first it equals the sum of each input times the input's weight plus a bias. Now we can never change the input, but we can change its weight, which would therefore create new subconclusions. Now, that process I just described to you is partial derivatives of the error, or cost of the network, with respect to each of the weights. And if you do that for each of the nodes of the network, then we'll think differently, weigh input differently, and come up with better conclusions. Fortunately, you don't need to be good at math to do this. In the next video, I will do a handwritten example where I will, first, manually feed input data into the network and make a conclusion. Next, I'll calculate the cost of the network, the error, and calculate the error of each weight. Finally, I will update the network's weights towards the correct conclusion. After that, you'll have everything you need to know to build your own neural network. If you like this video, please hit that like button and hit that subscribe button. It helps this channel grow and make the content better. I'll be doing more projects along the way. And I'll do shoutouts to videos that I use for research and include the links. Any questions, please use that comment section below, and have a wonderful day and be your own successful. The two videos I want to give a shout out to that helped me with my AI research and inspired this video series were the first one by 3 Blue 1 Brown, What is a Neural Network? It's a great series, I recommend you all check it out. It's a great series for understanding the theory and what they are. In the second video by Naveen Kumar, Backpropagation and Neural Network, his video is a great one because it does a handwritten example, which I'll be doing in the third video.